Today we're going to be focusing on figuring out the number of outcomes in a situation or an event, so pretty much counting the number of outcomes that are possible. So we call this the fundamental counting principle, and that's what our objective is going to be, pretty much figuring out strategies to figure out the sample space of an event, and we're going to be working on drawing those tree diagrams and also figuring out the total. So like, for example, have you ever seen or heard the Subway or Starbucks or any other restaurant or company advertise that they have 10,000 different ways or combinations to order your sandwich or your drink? And it all has to do with them claiming this because they're adding up all the different types of milk or condiments, or you can put lettuce, you can put something like spinach, you can or you can't, you can choose this or you can choose that as an option. So that adds up. So the more options you have, the many more different combinations you can make. That's why the number gets so big, like 10,000. So again, these companies use these two general ideas, which are tree diagrams. So we're going to see what it looks like visually, and something called the fundamental counting principle. So again, a tree diagram is just a diagram used to show the total number of possible outcomes in a probability experiment. So again, you should be filling in those words. So again, this is kind of what a tree diagram looks like. So it should pop up any second. So it just shows the number of different, for this case, the number of different outfits someone can pick from having 2 color pairs of jeans and 3 color shirts. So looking at the blue jeans, it splits off, so 2 sides, blue side on one side, black on the other side, and then from there it splits off 3 more times for the different color shirts. So in this case, there are a total of 6 combinations for this person to pick an outfit from 2 pairs of jeans and 3 shirts. So here are some more examples of some tree diagrams. So here we have the choices when it comes to having the choice from 3 pairs of shoes in terms of color, so black, white, and red sneakers. And then from each of those, we have 4 choices of picking our cap: red, blue, black, and tan. So at the end of the day, we have a total of 12 choices if you were just to count them all down. Here's another visual of what a tree diagram looks like. Let's say we flip a coin 3 times. The first time, heads or tails. After we flip heads, you can flip it again and have the choices of heads and tails again. So that's 4 total options. And from there, we flip it 1 more time, and then there's a heads and tails for each option. So if I look at the very top one on the right, that's from getting heads, heads, and heads. The second one is from getting heads, heads, and tails. The next one is from getting heads, tails, and heads, and so on. Here's another tree diagram. So this tree diagram is representing the outcomes when I spin a spinner twice. So spinner 1, the options are 1 and 2 and 3. And the second spinner has options of 4, 5, 6. And at the very right, we have all the possible outcomes, 1 with 4, 1 with 5, and so on. Again, sometimes tree diagrams aren't going vertically down. Let's say you're going to buy a new car. You have a sedan or a station wagon, and then from there you can have a choice of 5 colors, so that's already 10 options. And at the bottom you can do the trim on it, GL, SS, SL, and so on. So at the end of the day, we have a whole bunch of options. So we have about 30 options to pick from in terms of picking your new car from 2 types of cars, 5 types of colors, and 3 types of trims. Here's another vertical tree diagram from flipping a coin, heads or tails, and then rolling a die. And there are a total of 12 different ways that can happen. So second thing we're going to focus on is the fundamental counting principle. If one event can occur in M ways and another event can occur in N ways, so like 2 things are happening, then the number of ways that both events can happen together is just M times N. So it's just a multiplication. So we go back to the previous one. The car, there were 2. The colors, there were 5. And the trims, there were 3. So 2 times 5 times 3 would give us a 30 at the bottom. Second one for the coin, we have 2, and then we have 6. So 2 times 6 is a total of 12. So as we can see here, there are a total of 12 options at the bottom. So that just came from 2 times 6. So that's a total number of combinations. That's what the fundamental counting principle is telling us, that we just multiply, and it can be extended to more than 2 things happening. So let's go ahead and get into our first example. So let's say we have a new polo shirt. It's released in 3 colors and 4 sizes. how many color and size combinations are available to the public. So how many different combinations can be made from this? So let's go ahead and see that. So the general idea is number of possible colors is 4, number of possible sizes is, 3, number of possible sizes is 4. So there are a total of 12 combinations to make this polo shirt to purchase. So you can do it in 12 different ways. Now we're just going to go ahead and do a tree diagram for this. So again, we have 3 colors and we have 4 sizes. So it doesn't matter which way you do your diagram. So I'm gonna do it sideways. So we're gonna have, let me look at it one more time, 4 colors and 3 sizes. Let me go back and look at it real quick. I'm sorry, I forgot. 3 colors and 4 sizes. So let's go ahead and do that. So we have 3 colors and 4 sizes. So I'm gonna go ahead and write down those 3 colors. I'm gonna have my red, my blue, and my green. These are my 3 color options, and from there I'm gonna split them off into the different sizes. So I know from my color choice, I'm gonna split off to 4 possible sizes, which are small, medium, large, and extra large. Same thing for if I buy a blue shirt, I can still buy the blue shirt in small, medium, large, and extra large. And if I buy the green shirt, I can also buy the green shirt in small, medium, large, and extra large. So as you can see here, we have a total of 12 combinations. So again, this is the tree diagram, but again, we can do the faster way using that fundamental counting principle where we just take 3 options times 4 options, which gives us a 12. So again, on the left side, we have the tree diagram. On the right side, we have the fundamental counting principle. Obviously, the one on the right is generally easier, but sometimes we may need to draw that tree diagram based on the question. So let's go ahead and move on to the next problem. So we have 10 to go through. So just as a quick side note, tree diagrams and the fundamental counting principle are 2 methods for finding the sample space, the total. However, tree diagrams work better for some problems, and the fundamental counting principle works better for others. So let's look at example 2. We go to a snack bar to buy a bagel with cream cheese and a drink for lunch. So 3 things we're going to be picking from. You can choose from a plain bagel, blueberry bagel, or a raisin bagel. So there's 3 types of bagels. You can have strawberry, onion, or plain cream cheese. So 3 types of cream cheese. And then we have choices for a drink. We can have water or a sports drink. So we have 2 choices there. So how many different lunches can be made with these? All we have to do is multiply. So from the 3 bagel choices, we can choose 3 cream cheese choices, which then allows us to choose 2 drink choices. So 3 times 3 is 9. 9 times 2 is 18 combinations. So there are a total of 18 lunches that we can make with these choices. Let's go ahead and move on to the next one. All right, if a lottery game is made up of 3 digits from 0 to 9, how many number combinations are there? So again, there are 3 options. So I'm going to just kind of put that there's 3 options here. And we can put the numbers 0 through 9 in each of these sections. So we're going to see what we can put. So from 0 to 9, how many numbers are there? So there are 10. Don't get tricked by saying 9. It should be 10. 0 to 9, there are 10 numbers. In the second spot, we can pick any 10 numbers, and so can we on the third spot. So again, we can have things like 2, 2, 2, like 1, 5, 7 can be the numbers that get pulled for the lottery. So there could be repetition. They didn't say we couldn't have it. So what's 10 times 10 times 10? There are 1,000 combinations that can be picked for this lottery. Let's move on to the next one. So how many outfits are possible from a pair of jeans or khaki shorts and a choice of yellow, white, and blue t-shirts? So for our khakis, we can go ahead and choose 2 different choices. So I'm going to go ahead and do A. And for our shorts, we have 3 choices, which gives us a total of 6 choices. Part B says how many of the outfits will have a blue shirt. So we're going to go ahead and do that next. So I'm going to go ahead and move to the next slide. just to rewrite what we had previously, 2 times 3, which gave us 6. So let's go ahead and do a quick tree diagram so we know how many outfits will have that blue shirt on them. So here I'm going to write down the jeans or the khakis. I'm just going to abbreviate. And we have 3 combinations for each of these. We have blue, yellow, or white, blue, yellow, and white. So we look at our final results, which is, this is my final outcomes. How many of these have a blue shirt? We have 1 and we have 2. So the answer would be 2 outfits will have a blue shirt. Make sure you write this down. Positive need be, but I'm going to move on to the next one. All right, Scott has 5 shirts, 3 pairs of pants, and 4 pairs of socks. How many different outfits can he make? So again, for our first option, we have 5. Second, for those pants, there are 3. Socks, we have 4. 5 times 3 is 15. Times 4, we get 60. So he's got a total of 60 combinations that he can pair together to make his outfit for the day. Number 6, let's go ahead and move on. Give it a second. There we go. So how many 7-digit telephone numbers can be made using the digits 0 to 9 without repetition? So here we cannot keep using like 9976, 6433, and so on. So we're going to have 7-digit combinations, so we have to make sure we don't repeat. So again, there's got to be 7 digits. Sometimes it helps to actually just write down the spaces, 3, 4, 5, 6, and 7. So on the first choice, we have 10 options to pick from. For the second one, since we cannot have repetition, we have 1 less number to choose from, so now we have 9. So now that we've used the 2 numbers for the next option, there's only 8 left to pick from, and then it keeps going down 1 at a time. So it's going to be 10 times 9 times 8 times 7 times 6 times 5 and times 4. If you go ahead and multiply all these numbers together, use your calculator, of course, you're going to get 604,800 different telephone numbers that can use the number 0 through 9 without repetition. Let's look at example number 7. This one we're going to be asked to draw a tree diagram when Adam tosses a coin 3 times. We're going to draw the picture showing the possible outcomes and what is the probability of getting at least 2 tails. So let's go ahead and do that. So again, 3 times, and we want to get 2 tails. So I'm going to go ahead and draw my coins. My first option for tossing a coin is getting a tails or a heads. Then from there, I'm tossing it again. Options are tails and heads or tails, however you want to write it. And then he's going to toss it a 3rd time, so from here he can do tails, heads. Here, same thing, tails, heads. Same thing for these 2. And we have a total of 1, 2, 3, 4, 5, 6, 7, 8. So there are a total of 8 outcomes. But the question was, how many of these are going to have at least at least 2 tails in them? So we have to look at it across. So this first option, so I'm going to actually erase this so we can write it out. So which of these options means that it has 2 tails? So this first one right here, I'm going to highlight it in a different color so we can see it. So the first one, this top one comes from these 3 right here, which is going to be 3 tails. The next one is going to come from 2 tails and a head. The next row is from tails, HT, tails, heads, tails. Tails, heads, heads. So I'm just kind of going down the rows and looking at how it works. So this is the top one again. I'm going to write that it's HTH. Next one is HT. I'm sorry, I messed up on that one. Sorry. HTT. The second one is HTH. Next one is HHT, and the last one is HHH. So these are my 8 combinations, and we are looking for the ones that have at least 2 of the tails. So I'm going to go ahead and circle those. So the first one has 3 tails, which is at least 2. This is at least 2. This is at least 2. This is only has 1. This one has 2. This one only has 1. The next one has 1, and the last one has at least, no, that doesn't have any at all. So there's a total of 4. So it's 4 out of a total of 8, which reduces down to 1/2. So there's a 50% chance that you'll get 2 tails when you flip a coin 3 times. Let's go ahead and move on to the last ones. So you are planning to take 3 courses at a community college, a geometry. Actually, I'm going to stop the video now because I think we're out of time. I'll make another one for the second part.